Problem 6. Let's first calculate how many adults own both cars and motorcycles. So we use 331 plus 45, subtract the total number of adults, 351. That will give us the number of adults on both cars and motorcycles. That equals 25. Then we use the number of adults that own cars, subtract 25. That gives us the number of people that do not own a motorcycle. That is 306. The answer is D. Problem 7. Let's assume each of the 4 large congruent squares has an area of 1. For the first square, the upper left, the bolded area is 1/4 of the large square, and the second one on the upper right, the bolded area is 1/8 because it's half of the small square. And the third one on the lower left, its area is 1/4, that's one small square, plus 1/8, that's a triangle. And the last one, the bolded area is 1/4, and that sums up to be 1, because the total 4 large congruent squares has an area of 4, so the bolded area 1/4 multiply 100%. That's 25%. The answer is C. Problem 8. Because there are only 3 chips in each bag, we can write the values out to count the different values. If the first bag we have chip labeled 1, it adds the 3 values for the chips in the second bag. We will get 1 plus 2 equals 3, 1 plus 4 equals 5, 1 plus 6 equals 7. And if in the first bag we choose chip labeled 3, we will get 5, 7, 9. And if the first bag we choose chip labeled 5, we will get 7, 9, 11. Now let's count how many different values. The first row, the values in the first row are all different, and the second row we will have the last number different, and the third row we will also have the last number different. So we get 5 different values in total. The answer is B. Now it's worthwhile to look at this problem in a more generalized way. Let's assume bag A and bag B both have N chips, and bag A has chips labeled as odd numbers 1, 3, 5 until 2n subtract 1. And bag B has chips labeled as even numbers 2, 4, 6, 8 until 2n. In this case, when we choose the chip labeled 1 to start, the chips in the second bag, they add 1, we will get 3, similarly 3, 5, 7, 9 until 2n plus 1, and that's n numbers. And the second row, we choose the chip labeled 3 in the first bag, it adds the different values in the second bag, we will get 5, 7, 9, 11 until 2n plus 3. Similarly, the third row will be like this. Until the last row, we will get the first will be 2n subtract 1 plus 2. That's 2n plus 1. Until the last two numbers, their sum is 4n subtract 1. And this will be n subtract 1 rows. So now let's again look at the different numbers. The values in the first row will all be different. Therefore, we have n different numbers. But from the second row on, we will only have the last number different. The previous n subtract 1 numbers in this row will be a repeat from the second number to the last number of the previous row. So this also applies to all the other rows underneath. So we will have n subtract 1 different values from the second row to the last row. They are all the last numbers in each row. Therefore, the total different values will be n plus n subtract 1 equals 2n subtract 1. And in the problem, n equals 3 and 2n subtract 1 equals 5. That's why we get answer B. Problem 9. From the chart, the entire ride, she took 7 hours and the total mileage is 35. So to calculate the average speed, we use 35 divide 7. That equals 5 miles per hour. The answer is E. Problem 10. Let's assume we can ride X miles because the first half mile is $2.4 and then after that it's $0.2 for each 0.1 mile. So we use their division to get the price and we multiply X subtract the half mile and then we add the $2 tips. That should sum up to be $10. Now let's simplify. This will be 2.5 plus 2x plus 1 equals 10. Therefore, we solve this equation, we get x equals 3.3. The answer is C.